Welcome to this CipherVibe Cloud Security Guide. Today, we will make how to secure any cloud platform, step-by-step security guide for 2026 practical, prioritized, and connected to how real cloud environments are operated. Securing any cloud platform is not memorizing 4 different consoles. It is building one operating model that works across AWS, Google Cloud, Azure, and Oracle Cloud, organize the environment, control identity, limit network reachability, protect data and keys, centralize evidence, enforce guardrails, and practice response. This guide maps the same security thinking onto provider-specific services: AWS Organizations, IAM, VPCs, CloudTrail, Config, GuardDuty, KMS, and Security Hub, Google Cloud Organization, folders, projects, IAM, VPC Service Controls, Cloud Audit Logs, Security Command Center, and Cloud KMS, Azure Entra ID, Management Groups, Subscriptions, RBAC, VNets, Defender for Cloud, Azure Policy, Key Vault, and Monitor. Plus OCI tenancy, identity domains, compartments, policies, VCNs, Cloud Guard, Security, Zones, Vault, and Audit. The purpose is not to memorize a collection of service names. It is to build a mental model you can apply when accounts, teams, workloads, and threats change. We will define the core ideas, walk through a repeatable security workflow, examine mistakes that frequently create exposure, design useful safeguards, and finish with a practical hardening roadmap. Pause when you need to. Write concepts in your own words, record observations, and distinguish what the evidence proves from what you are merely assuming. That habit is more valuable than rushing through another tool demonstration. Start with 4 concepts that provide the vocabulary for how to secure any cloud platform. Step-by-step security guide for 2026. First, start with hierarchy and blast radius. AWS accounts and organizational units, Google Cloud folders and projects, Azure management groups and subscriptions, and OCI compartments define where ownership, policy, logging, budget, and emergency isolation happen. Second, identity is the control plane, AWS IAM and IAM Identity Center, Google Cloud IAM and service accounts, Azure Entra ID and managed identities, and OCI identity domains and dynamic groups all decide who or what can change infrastructure. Third, network reachability is not trust. VPCs, VNets, VCNs, subnets, gateways, routing, firewalls, security groups, NSGs, private endpoints, service perimeters, bastions, and load balancers must be designed around data sensitivity and administration paths. Fourth, data and keys need a separate model. S3, cloud storage, Azure storage, OCI object storage, managed databases, secrets managers, KMS, Cloud KMS, Key Vault, and OCI Vault all require access, encryption, rotation, logging, backup, and restore decisions. Fifth, telemetry is the evidence layer. CloudTrail, Cloud Audit Logs, Azure Activity Logs, OCI Audit, Flow Logs, DNS Logs, Workload Logs, Posture Findings, Identity Events, and key events must be routed to protected destinations before incidents. Sixth, response is a designed capability. Every cloud needs tested playbooks for leaked credentials, public storage, exposed workloads, permissive firewall rules, overprivileged roles, disabled logging, suspicious identities, compromised keys, and recovery from backups. Do not study these as isolated definitions. Ask which asset or business service is involved, where the relevant trust boundary sits, which identity performs the action, and what reliable evidence would show that the control worked. Security reasoning is a chain. Source evidence supports an observation. The observation supports a conclusion. The conclusion informs a proportionate decision. The decision has an owner, an expected result, and a way to verify it. When any link is missing, say so. A professional explanation can include uncertainty without becoming vague. For example, a network record may prove that 2 addresses communicated, but it may not prove which human initiated the action or whether the content was malicious. Now turn the mental model into a repeatable workflow. First, inventory the estate first. List AWS accounts, GCP projects, Azure subscriptions, OCI compartments, owners, environments, regions, public endpoints, data stores, identity providers, privileged roles, and logging status. Second, harden identity before services. Enforce MFA for administrators, federate human access, reduce standing privilege, separate break glass identities, rotate stale keys, scope service accounts and managed identities, and review cross-account or cross-project trust. Third, create a network baseline. Map ingress, egress, routing, peering, private endpoints, exposed load balancers, open security groups, firewall rules, NSGs, bastions, NT, internet gateways, and management access paths. Fourth, centralize evidence. Send AWS CloudTrail, Config, GuardDuty, VPC flow logs, Google Cloud Audit Logs, SCC findings, Azure Activity Logs, Defender alerts, OCI audit, Cloud Guard findings, DNS, network, and workload logs into protected storage and CM workflows. Fifth, apply guardrails. Use AWS Service Control policies and config rules, Google Organization Policies and SCC, Azure Policy and Defender for Cloud, and OCI security zones and Cloud Guard to prevent or detect unsafe configurations. Sixth, protect data and secrets. Block unintended public access, classify critical stores, enforce encryption, restrict key administrators, rotate secrets, separate production keys, log access, and test backup restoration for each provider. Point 7. Practice response. Simulate a leaked AWS access key, exposed cloud storage bucket, Azure owner role abuse, OCI API key compromise, public database exposure, disabled logging, suspicious workload identity. Key rotation, network quarantine, and restore workflow. Before acting, define the objective, scope, owner, and success condition. Collect the smallest amount of trustworthy evidence needed to understand the situation. Preserve timestamps and sources so another person can follow your reasoning. Priorities should be explainable. Consider exposure, identity and privilege, sensitive data, business importance, exploit conditions, existing safeguards, reversibility, and confidence. A dramatic label should never replace that analysis. The workflow does not end when a command succeeds, a ticket closes, or a dashboard turns green. Verify the new state with fresh evidence. Check for recurrence and for side effects introduced by the change. This disciplined loop, observe, interpret, decide, act, verify, and learn appears in every cybersecurity specialty. Understanding failure modes will protect you from attractive but unreliable shortcuts. First, multi-cloud teams often copy provider defaults without designing hierarchy. Flat accounts, projects, subscriptions, or compartments hide ownership and make blast radius hard to control. Second, standing administrator access grows quietly. Overprivileged AWS roles, Google Service accounts, Azure role assignments, and OCI policies can turn one token or credential into broad control plane access. Third, public exposure is easy to miss because every provider names controls differently: security groups, firewall rules, NSGs, security lists, public buckets, public load balancers, internet gateways, public IPs, and database endpoints all need one review lens. Fourth, logs can exist, but still fail responders. If trails are incomplete, mutable, region-limited, not centralized, poorly retained, or not connected to alerts, the team may not reconstruct what changed during an incident. Fifth, posture tools are not a security program by themselves. GuardDuty, Security Hub, Security Command Center, Defender for Cloud, Cloud Guard, and security zones need scope, tuning, ownership, exception management, and closure evidence. Sixth, secrets and keys are frequently treated as implementation details. Access keys, service account keys, client secrets, API keys, auth tokens, customer-managed keys, and backup keys need lifecycle, monitoring, and emergency rotation. Point 7. A control that works in one cloud may fail in another because the identity model, inherited policy behavior, regional services, logging coverage, private networking, or managed service boundary is different. These mistakes often share one cause: confusing an available signal with a complete explanation. A tool can report a finding, a successful action, or a score while important scope, context, ownership, and verification remain missing. Also resist copying commands without understanding their inputs, outputs, permissions, and side effects. Run one controlled change at a time and record what happened. If an exercise does not behave as expected, that is useful evidence. Stop, inspect the environment, revise the hypothesis, and explain the difference. Good security work is not a performance of certainty, it is careful reasoning under imperfect information. Reliable security uses layers because no single control can prevent every failure. First, use a landing zone pattern per provider: AWS Organizations and Accounts, Google Cloud Organization folders and projects, Azure management groups and subscriptions, and OCI tenancy compartments with clear owners, tags, environments, and guardrails. Second, standardize identity hygiene: SSO federation, MFA, least privilege, privilege elevation workflows, break glass monitoring, service account review, managed identities where possible, stale credential removal, and quarterly access reviews. Third, standardize evidence: organization-wide CloudTrail, Google Cloud Audit Logs, Azure Activity Logs, OCI Audit, Network Flow Logs, DNS logs, posture findings, identity events, key events, protected retention, and alert routing. Fourth, standardize network exposure review: enumerate public IPs, internet gateways, load balancers, ingress rules, firewall rules, security groups, NSGs, security lists, route tables, peering, private endpoint coverage, bastion access, and admin ports. Fifth, use provider guardrails intentionally. Service control policies, AWS config, Security Hub, GuardDuty, Google Organization Policies, Security Command Center, VPC Service Controls, Azure Policy, Defender for Cloud, OCI Cloud Guard, and Security Zones. Sixth, protect data with private storage defaults, public access blockers, encryption, customer-managed keys for sensitive systems, secrets managers, key vaults, rotation, database auditing, backup immutability where available, and restore testing. Point 7. Make response executable with runbooks, automation boundaries, evidence preservation, credential disablement, key rotation, workload quarantine, network isolation, owner escalation, backup restoration, and post-incident control validation. For each important risk, ask 5 questions. What makes the event less likely? What evidence would reveal it? Who can contain it? How will trustworthy operation be restored? Who owns the decision and accepts remaining risk? Least privilege applies to people, applications, devices, automation, data stores, and administrators. Access should be scoped, separated, monitored, reviewed, and removed when it is no longer needed. Every important control needs a test strategy. Include representative normal activity, negative cases, misuse, dependency failure, and rollback. A written policy is not evidence that a technical or operational control works. Finally, preserve the evidence trail from observation through decision, action, and verification. That history supports investigations, audits, lessons learned, and honest measurement. Turn this guide into a focused multi-cloud security hardening plan. Start by inventorying AWS accounts, Google Cloud projects, Azure subscriptions, OCI compartments, owners, regions, critical workloads, public endpoints, privileged identities, keys, secrets, storage, databases, and log sources. Then fix identity risk. Require administrator MFA, prefer SSO federation, remove stale users and long-lived keys, review service accounts and managed identities, reduce broad role assignments, monitor break-glass access, and document cross-account or cross-project trust. Next, centralize evidence. Protect CloudTrail, Google Cloud Audit Logs, Azure Activity Logs, OCI Audit, Network Flow Logs, DNS logs, posture findings, identity changes, key changes, policy changes, and storage access records. If evidence is not centralized and protected, the response team is already starting late. After the evidence layer works, close public exposure. Review security groups, firewall rules, network security groups, security lists, public IPs, load balancers, storage public access, database endpoints, route tables, peering, bastions, and private endpoint gaps. Then turn on guardrails deliberately. Use AWS config, GuardDuty, Security Hub, Google Security Command Center, Organization Policies, Azure Policy, Defender for Cloud, OCI Cloud Guard, Security Zones, and clear exception workflows. Each finding needs an owner, a severity rule, a remediation path, and closure evidence. Finally, test response. Drill leaked AWS keys, exposed cloud storage, Azure owner role abuse, OCI API key compromise, disabled logging, suspicious workload identity, public database exposure, emergency key rotation, network quarantine, backup restore, and executive reporting. Measure progress with percentage of cloud environments covered by centralized logging, administrator identities without phishing-resistant MFA, public storage buckets or containers by owner, critical posture findings older than 7 days, long-lived keys and secrets by age, internet-exposed workloads with sensitive data paths, successful restore tests for critical cloud workloads. Each metric needs a precise definition, a reliable source, an owner, a review schedule, and a known limitation. The strongest multi-cloud security programs are not built from tool names alone. They are built from a repeatable operating rhythm, clear hierarchy, least privilege, narrow networks, protected evidence, enforced guardrails, protected data, tested recovery, and rehearsed response. For chapter markers and primary cloud provider links, open the description. For more evidence-based cybersecurity research, visit CipherVibe.com and subscribe to CipherVibe. Copyright 2026 CipherVibe. All rights reserved. This briefing is general education. Validate controls with authorized administrators in your own cloud environments.